Dear students, welcome back to the class of Electrostatics Chapter 2, and today let's study about dielectrics and polarization. What are dielectrics? Dielectrics are insulators or they are non-conducting materials which have very less number of charge carriers. Now we are going to study what happens when a dielectric is placed in an electric field. To understand the effect of electric field on a dielectric, we must learn about the different types of molecules. Molecules can be classified as polar molecules or non-polar molecules. You have studied that in chemistry. Now, what are non-polar molecules? In a nonpolar molecule, the centers of the positive and the negative charges coincide. Example, oxygen or hydrogen. When two hydrogen atoms combine to form a hydrogen molecule, their centers of the negative and positive coincide. Or we can say hydrogen is a symmetric molecule. But in the case of polar molecule, the centers of the positive and the negative charges do not coincide or they are separated. So, they will always have a permanent dipole moment. Examples are HCl molecule, H2O molecule, etc. When a hydrogen atom, an oxygen atom, and a third hydrogen atom combine to form a water molecule, the positive and negative do not coincide. But whether a molecule is polar or non-polar, when it is placed in an external electric field, every molecule will develop a net dipole moment. And this dipole moment per unit volume is known as the term polarization, represented by the letter P. Now, polarization is directly proportional to electric field, or it is equal to a constant into the electric field. This constant is called chi, Greek alphabet chi, and it is called the electric susceptibility. So, what is electric polarization? Dielectric polarization is a term used to describe the behavior of a material when it is placed in an external electric field or an external electric field is applied on it. Next topic is capacitors and capacitance. A capacitor is a system of two conductors separated by a dielectric or an insulator. You can see in the diagram two conductors, plate 1 and plate 2. It is separated by a green colored dielectric or insulator. Now this is the symbol of a capacitor. You know the symbol of a cell or one single battery. One small line, a big line. Smaller one negative, bigger one positive. But in the case of a capacitor, both the lines are having equal size. Now the capacitance C depends only on the geometry of the system, that is the size of the two metals, and also on the type of material that is used as an insulator or the dielectric material. So let us find out the unit of capacitance. To find out the unit of capacitance, we know that the potential difference V between the two conductors is directly proportional to the charge. That is, charge Q is proportional to the potential difference V, or Q is equal to C into V, where the constant C is called the capacitance. So, from the formula Q is equal to CV, we know that C is equal to Q by V. So, to find out the unit of capacitance, let us use the formula C is equal to Q by V. So, unit of capacitance is the unit of charge divided by unit of potential difference. What is the unit of charge? Coulomb, and potential difference volt. So, unit of capacitance is Coulomb per volt, and it is called farads, and it is named after the famous scientist Michael Faraday, the father of electricity. Now you have studied about resistances connected in series and resistances connected in parallel. What is the formula for effective resistance in series? R equals R1 plus R2 plus R3 plus etc. And when resistance are connected in parallel, we know that 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. Now similarly, capacitors can also be connected in series and parallel as shown in the diagram. Now the formula for effective capacitance is the opposite of effective resistance. When capacitors are connected in series, the formula is 1 by C equals 1 by C1 plus 1 by C2 plus etc. And when capacitors are connected in parallel, then the formula for effective capacitance is C is equal to C1 plus C2 plus C3 plus etc. That is opposite of resistance formula.